Hello, welcome back. In this video, we're going to practice implicit differentiation for two different functions. And here, I just want to step back and then stare at those functions. One of them is like x squared y plus y squared x equals -2. So this function is not given in the explicit form because if it was, then it would be written as y equals a function of x, but x and y variables are pretty mixed here, so that's why we call this type of expression to be implicit type expression. So then we have to use the implicit differentiation rules. Well, if you look at the second one is as well not given explicitly because it's not in the form of y equals some function of x. But since we know the trig functions and we practiced that in the pre-calculus session, we can just solve this equation for y. In other words, we can write this as y equals secant inverse of x. These two expressions are equivalent, but this is now explicit and this one is not. Unfortunately, we do not have any rule yet to take the derivative of inverse functions. Indeed, the derivatives of inverse functions will be the main topic of the next section. So since we don't have any rule to take care of this or to take care of the derivative of this explicit description, we will still use the implicit differentiation to take care of x equals secant y. The guideline goes like this. Well, since the function description is implicit, we're going to take the derivative of the full equation. We will just keep in mind that y is a function of x. So whenever we see y and we need to take the derivative of that, we will know that we're taking the derivative of a function of x. Once you're done with the differentiation of both sides of the equation, you collect dy over dx or y prime terms in the left-hand side of the equation, and then the rest is collected in the other side. And on the left-hand side, we factor dy over dx or y prime out, and then solve for dy over dx or y prime in the next step. All right, so let's apply this guideline for part A. All right, now we're taking the derivative of this whole equation. The derivative of the left-hand side, since we have two different terms here, is the sum of the derivatives of each piece. And the derivative of the right-hand side is a derivative of a constant. So this derivative is going to turn out to be 0 because it's the derivative of constant. But the left-hand side, we're going to be very careful because we have the derivative of the product of two functions here for this one. Likewise, we have the same thing going on here. So we're going to utilize the product rule that we learned in the earlier section. All right, the application of the product rule to the first term yields, well, the derivative of the first function here, which is x squared prime, times the second function y in the list, and then plus the first function times the derivative of the second function. That takes care of the derivative of this term. And for this one, we take the derivative of x multiplied by y squared, there we go, plus we keep the first and multiply it by the derivative of y squared, and then the right-hand side is the derivative of the constant -2. One thing that we should be careful, so this y prime term is fine, but this one is a derivative of y squared, so we have to use the general power rule because you have a function of y raised to the power of 2, and you take the derivative of that. The derivative of this is going to be 2 times y, as if you're using the power rule, but since y is a function of x by the chain rule, 2y, this turns out to be 2y times y prime. So now we're gonna keep the y prime terms in the left-hand side of the equation, and then send the other terms to the right-hand side of the equation and solve for y prime. All right, once we factor y prime, we have x squared plus 2xy left, so x squared from here, and 2xy from here. And on the right, we still have minus y squared minus 2xy. So all we're going to do is to divide both sides by this factor here. And it turns out that y prime is exactly equal to minus y squared minus 2xy divided by x squared plus 2xy. All right, Let's move to part B. So the derivative of the left-hand side is exactly equal to 1 because it's the derivative of x. And the derivative of right-hand side is the derivative of secant of a function because y is a function of x. So it should be secant y tangent y, which is just the derivative of secant function, times the derivative of the inner function. So just take it as like secant is the outer function. So the derivative of secant is secant tangent, secant y times tangent y. And the derivative of the inner function is just y prime. You can easily solve this for y prime. All we're going to do is divide both sides of the equation by secant y tangent. You don't need to recollect all the terms in either side of the equation. So y prime turns out to be 1 over secant y tangent y. All right, at this moment, you can just stop and conclude that y prime is 1 over secant y tangent y. I want to remind you about the reciprocal identities that we practiced in the pre-calculus session. So secant is the reciprocal of cosine, and tan is the reciprocal of cotangent. So you can conclude that y prime is equal to cosine y times cotangent y. Well, this takes care of part B. That is the end of the video. Thanks for watching. I'll see you in another video. Bye.